In the last Experiments in Thought, we discussed why a mass distorts spacetime that results in gravity. This time, we will discuss the reasons why the time frames across the universe levels can be so profoundly different. At the end, I'll give you another awesome thought that might keep you awake at night. Just for the purpose of these videos, I will refer to the infinite regression of universe levels, both up and down, as the firmament. Imagine the firmament as being created all the time, and at the same time, having always existed. So why are the time frames of the many universes so different? The time frame for a particular universe is the rate at which time passes from one second to another, which is not constant across the firmament. There are no set rules as to how the physical laws of nature should be applied to each universe bubble, or why all universes should be created the same. This means that the difference in the physical laws from one universe bubble to another can be very extreme. But if the conditions go beyond certain levels, the universe becomes unstable, the conditions can't sustain a viable existence, and so the universe immediately bursts. There are no limits on what any of the individual physical laws can be. What makes a universe viable is how the different laws interact with each other to create the right conditions for the universe to exist. It's similar to all the right conditions coming together to support life, such as the right amount of light, heat, gravity, and water. Without them all working together, life on Earth wouldn't be viable. An example of a physical law that can vary is the mass of the elementary particles that make up the matter in a universe. This mass would result from the time differential boundaries of the elementary particle bubbles on the next universe level down. Imagine if the time differential boundaries of those universe bubbles were too weak to result in a big enough distortion in spacetime. The resultant gravity may be too weak to enable the particle bubbles to interact to form structured matter, stars and galaxies. So although that universe may be viable, it may only exist as a cloud of amorphous matter that can't exist in a structured way that we are familiar with in our universe. Now imagine another universe having been created, where the resultant gravity is too strong for structured matter to exist. The universe may also be viable, but all matter in that universe might only exist as a single super massive black hole at its center. Another example of a physical law is the constant, c for the speed of light, the value of which is not constrained by any rules. The constant, c, can be any value, and it determines what the time frame is for that universe. This means that the inhabitants of every universe in the firmament will all experience the passage of time in exactly the same way. They will all measure the speed of light traveling at the same speed, because light speed relative to its time frame is always constant. The difference in time frames between our universe and a nearby universe could only be seen if a hole appeared in both time differential boundary bubbles. You would then be able to see into the nearby universe, and time passing at a different rate relative to the time frame of our universe. The previous video discussed the reasons why it is not possible to see beyond time differential boundaries. Now imagine a universe bubble as an elementary particle in our world, in the next universe level down. Its laws are likely to have a different value of c than in our universe, and there are no rules about what that value can be. So the time frame for a viable particle bubble is determined by its value of c, and the difference in the time frame from our world will create a time differential boundary where the two time frames meet. It could be that the physical laws of that elementary particle are very similar to our universe. In this case, the time frames would be very similar or the same, there may not be a time differential boundary, and there would be no distortion in space-time and therefore no gravity. This would give rise to an elementary particle that would have no measurable mass in our world, such as a photon or a gluon. Put that same elementary particle in a different universe with a different time frame, and it would create a time differential boundary, and manifest as a different flavor of particle that has mass, such as an up quark or a down quark. Now, imagine that massless elementary particle in our universe having exactly the same physical laws as our universe, with no time differential boundary. It means that an inhabitant of that universe could theoretically travel into our world, unhindered. If any aliens do travel into our world, we wouldn't know of their presence because they would be far too tiny to be detectable. Their matter would consist of elementary particles that exist as two universe levels down from ours in the firmament. As in the previous video, this hypothesis cannot be completely proved or disproved, or modeled in existing earthbound mathematics. So it will always remain as just an experiment in thought. Thank you for watching. Please leave any questions or comments below. Coming up, in the next experiment in thought video, we will discuss the true origin of the Big Bang, and why they are happening all the time.